Okay, forgot to record at the beginning, but we are talking about simplifying radicals, which is the same as simplifying square roots. This is a square root symbol. We also call that a radical. Oh my God, they need to take your test. Come get them. You put your phones up there? Your backpacks up there? Okay. I'll make sure you have a calculator. Oh, thank you. All right, so there are cube roots, quad roots, all kinds of roots. We only have to worry about simplifying square roots, right? This is an example. The square root of 25 we talked about is 5, because 5 times 5 gives you 25. So when we take the square root of something, we're looking for its identical factor, that when you multiply by itself, you get that number under the radical. So this is a perfect square, simplified very easily. This is not a perfect square. It's approximately 11.313 ... But it can be simplified. And before we do this bigger one, we're going to talk a little bit more about them. So the third example, we're going to simplify the square root of 20. So we are going to write simplify here. And the way that we're going to do that is we're going to break this square root down into factors. But we're looking for special factors. We're looking for the biggest square root factor of 20 that we can find. Okay, so the square root factors. So we could rewrite this. So the factors of 20, 1 in 20, 2 in 10, 4 in 5, and that's all the integer factors of 20, right? Are any of these factors a perfect square? No. All right, so let's talk real quick before we go any further. So 4 is a perfect square, and it's in fact the only perfect square factor of 20, so we're going to use that one. But before we get any further, we should know the perfect squares, these perfect squares. You should recognize them. They'll make your life on this stuff a lot easier. We should know that the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, square root of 25 is 5. Right, 6 times 6 gives me 36. That makes that the square root. What's the square root of 49? 7 times 7 is 49. What's the square root of 64? 8 times 8 is 64, right? That's what a perfect square is, a product of two identical factors. This is 9, 10, 11, and 12. So here, I'm looking for square root of a perfect square. So this, I can rewrite 20 using these factors, because 4 is a perfect square. I could rewrite this as the square root of 4 times the square root of 5. I'm telling you that those are equivalent. Does that make sense to you guys? You know, 4 times 5 is 20, so the square root of 4 times the square root of 5, it makes sense that that would be the square root of 20, right? Well, what is the square root of 4? Right, so now, this is 2 times the square root of 5. So the square root of 20 simplifies to 2 times the square root of 5, and that's how we write it. 2 square root of 5. Just like a variable term, the number on the outside of that radical is called a coefficient, just like if we had 2x, 2 would be the coefficient. Just like in 2x, it's 2 times x, this is 2 times the square root of 5. Okay? Let's do this. On your calculator, clear your calculator out 3 times. Put in 20 square root of x. Tell me what you get. 4.72, and it goes on forever, right? Now on your calculator, do 2 times 5 square root x. Tell me what you get. 2 times 5 square root of x. Equals. You gotta hit equals.
I got 3.162.
Okay, you guys did not, yes. So this one, the square root of 20 is not 4.72 on your calculator.
4.47.
Yeah. On your calculator, the square root of 20 is 4.472 blah, blah, blah. 4.472 ... If you take the square root of 20 on your calculator, that's what you get. Everybody see that? Now let's do 2 times the square root of 5. Does yours say DEG? Right? Is it in the right spot?
Yeah. That's what 2 times 5 is.
No. 2 times 5 is the square root of x7. 2 times 5 square root of x equals.
Oh.
Right, so that brings us to a good point. To find the square root of a number, you're going to do it backwards on your calculator, right? So if you want the square root of 20, you put in 20 and then hit the square root of x. I said that when I told you what to enter, but I didn't explain that. So what we're doing is we're breaking this down into perfect square factors. So in order to simplify, if you didn't write these down, make sure you go ahead and write those down. Those will help you. In order for a radical to be simplified, it can't have any perfect square factors under the radical, right? So simplified means, you're writing what I'm writing, no perfect square factors under the radical. And we're going to put under the square root symbol. So there can also be variables underneath here. Okay? So we're going to be working with those as well. But we're going to do a couple more examples without variables, and then we'll get to so let's go make example 4, the square root of 128. So do you know any perfect square factors of 128? So if you don't, then you start making a list of factors like we did. So 1 times 128, well, 128 is not a perfect square. If you're not sure, put it on your calculator. 128 square root of x, and if it's got a decimal, it's not a perfect square. What is 128 times divided by 2? 64. What is 1? It is a perfect square. And guess what? That would be the biggest one. Basically, if it's on the right, on these big ones, the first one you get to on the right is going to be your biggest one. So 2 times 64 is 128. So we can rewrite this as the square root of 2 times the square root of 60. Actually, let's do it this way. So 64 is on the right here, but I'd like for you to write the perfect square on the right side. It doesn't matter, but you will have to move it if you don't do that. So when we factor it into a perfect square and the other factor, let's put the perfect square first. So 64 is the perfect square. Let's do it. Square root of 64 times the square root of 2. The coefficient always goes on the left of the radical, just like on a variable. So that's the only reason I moved it there, because that's going to wind up being your coefficient. What is the square root of 64?
8.
Right. So this simplifies to 8 square root 2. Just like with the variable, you don't need an operation symbol in there. 8 square root 2 means 8 times the square root of 2. And that is your answer for the square root of 28. Make sense?
Yeah.
Okay. Let's do something a little bit different. Let's do example 5 is going to be the square root of 72 x cubed. So now we've got to factor the numerical part, the coefficient underneath here, and the x, the variables. We've got to factor those into perfect squares. Well, the easy part about the variables is it's just whatever the variable is to the second power, right? So this is a perfect square factor. So x squared times x, that equals x cubed, right? All right. So this is our perfect square. What's the square root of x squared? X, that's right. So now we're going to factor this and factor, so these are the factors of x cubed. So now let's factor 72. Well, 1 times 72, 2 times 36. Have I gotten to any perfect square factors yet? What is it, Jacob?
Yeah.
36. Good. So now let's rewrite 72. Actually, yeah, let's rewrite 72 as the square root of 36 times the square root of 2, right? That's what we did here. Now let's write the x squared as the square root of x squared times the square root of x. Does that make sense? Square root of 36 times 2 is the square root of 72. And you can break it down here if it makes more sense. Square root of 72 times the square root of x cubed. If you want to do that, you can.
Right.
So this are the factors of this. This are the factors of this. Does that make sense, Caleb Berry? Does that make sense, Caleb Davis? Does that make sense, Faith? All right, so what is the square root of 36?
That is 6.
All right, so this is 6 times the square root of 2 times, what's the square root of x squared?
X.
And that's going to be times the square root of x, because that's not a perfect square, so that's going to stay under the square root symbol. So now all we have to do is put everything together under the radical and the outside things together. So the x moves over here with this 6, so that's 6x. And now the square root of 2 times the square root of x is just the square root of 2x. So that is the simplification of the square root of 72x cubed.
That didn't seem too hard.
It is not too hard, but you're going to have to practice it. Any questions? Right, so I think I uploaded some examples. Oh, I wrote you some steps. I don't know. You want those steps or no? Linda will come back if we have time. They're kind of wordy. I'm kind of wondering if they're the best steps for you guys. Oh, let's look at one like example 7. I think this is going to be example 6 for us though, right?
Yes.
Yes. So example 6. This is the same as 2 times the square root of 45, right? Does that make sense to y'all? Remember? You don't need that there. We have to include this 2 in our answer, but we have to simplify this radical first. So 2 times, so the factors of 45, 1 and 45, 3 and 15. Any perfect squares yet?
No.
4 is not. 5 and 9. Any perfect squares yet?
No. Wait. Yeah.
9, right? So let's write the perfect square first. So times the square root of 9 times the square root of 5. What's the square root of 9? 3. So this is 2 times 3, which is 6 square root of 5. That's it.
Oh.
So there's an example on the back. So what if we're taking the square root of a fraction? So let's look at one of those. So that was example 6. I swear I put a worksheet in here. There we go. So let's do number 21. That's going to be example 7 for us. Example 7. So if you can't read it, I'll put it over here. Example 7 is the square root of 36 over 25. All right, so the thing you should know here is this is the same as the square root of 36 over the square root of 25. So now, what is the square root of 36? What's the square root of 25?
Uh,
And that is your answer.
what?
Where is this one? I think that we are not going to do all the evens because we're not going to rationalize that there's 9 and plus tomorrow. So let's do even 2 through 28 even. You guys are going to do 2 through 28 even. We've got something else, something new to learn in there. Yep. Alright, 2 through 28 even, so let's see, let's look at one like, let's look at some. Well, we're going to do one like 12. We're not going to do your 12. You only have 14 problems. So 12 on yours looks like something like this one. All right, so let's do this one here. So 9a, ooh, it's similar. It's not exact. Let's do this one. So let me move it so y'all can see it. Make it bigger. So is this example 8? 9a square root of 243. All right. So there's 9 times a times the square root of 243. I have no idea what the factors of 243 are, so we're going to get started. I know 243 is not a perfect square. It's not divisible by 2. Let's do 243 divided by 3.
Yeah, anyway, that's pretty swift.
Ah, nice. So 3 times 81. So 81 is a perfect square, right? What's the square root of that? 9. Okay, so we're going to rewrite it. This is 9a times the square root of 81 times the square root of 3. Y'all with me? Square root of 81 times the square root of 3 is the square root of 243. So you guys just said the square root of 81 is 9. So now this is 9a times 9 times the square root of 3. That's exactly right. 9 times 9a is 81a times the square root of 3. Remember, you don't leave a dot in there for your final answer. I don't know. I have no idea. Oh, that's so sad that I just saw a sad thing. Okay. Yeah, about the guy dying. I was accident. I didn't mean to click on that. All right, let's do this example, 17. It's all variables, but it'll give us lots of good practice. So example 9 is going to be the square root of x, y to the 7th, z to the 2nd. It's not on your homework.
Is that a V? Wait, what?
It's a y.
Oh,
X, y to the 7th, z to the 2nd times x squared times y cubed. There's a couple ways to do this. I'm going to combine them and then simplify them. So this is going to be the square root of, that's a y.
That's what I think.
That's a y.
Oh.
So we're going to do x times x squared. What's x times x squared? X cubed. X to the first times x squared, you add the exponent. Y to the seventh times y to the third is y to the 10th. Z squared, there's no other z squared, so we're going to leave that by itself. So we haven't simplified. Right now we've multiplied them. Now we're going to break these down into their perfect square factors. Remember, all that means is in twos, right? So we're going to start here. The square root of x, it's got more than 2, so our first is going to be the square root of x squared. That's going to leave me the square root of x to the first. So I factor that. This is its perfect square factor. Does that make sense, Jacob? Does that make sense, Zariah? Okay. Now the y, we're going to start times y to the second times the square root of y to the second, so it's 2 plus 2 is 4. Thank you. We're not done yet because we need y to the 10th. Times y to the second, that's y to the 6th power. We're not done yet. Times y to the second, that's 8. Times y to the second, that's 10. Are you with me? Yeah. I got it too close to my edge here. I'm going to see if I can read it. Alright, and now we've got to do the z squared. Well, z squared is a perfect square, right? So what is the square root of x squared? And we can't do the square root of x to the first because that's not a perfect square. The square root of y squared?
Y squared, y.
Alright, so we got a bunch of those. So we're going to keep going until we're done with those. What's the square root of z squared?
Z.
Now remember, all these are multiplied.
It's only 5 of the one, so.
So this is going to be x times y to the 1, 2, 3, 4, 5, 5th power times z, right? That's, we've multiplied all those. What we did not put in our answer yet is the square root we have left. So that z squared was crossed out too. Times the square root of x. Any questions? And we're going to do at least one other example. We're going to do one like number 18, which is like your number 19 on there. All right, so we're going to do, whoops, I'm going to rewrite it so you can see it.
You couldn't move like 48. You got to go faster.
When you get a calculator, that'll multiply your fraction. Let's see, is there one with a fraction? I don't mind doing one with a fraction, but...
You do number 19 real quick, and see how. Because that one was hard.
Okay, we'll do number 19 first, and then if we have time, we're going to do one like 19. So we're going to do this example, example 10 is 4 times 15 hk squared times, I don't know why there's a dot and a parentheses there, but whatever, negative 8 times 5hk. Are you with me? That's just the example. So the first thing I'm going to do is I'm going to multiply coefficient times coefficient and radical times radical, and then we'll start simplifying. Well, y'all get caught up with me. All right, 4 times 8, negative 32. Now all the rest of this is going to be under the radical. So 15 times 5, 75. H times h squared. K squared times K,
K squared.
K cubed, right?
Oh.
That's got a 1 on it. If you don't see it, remember it's got a 1 on it. Everybody know how we got here?
Yeah.
Alright, so now, you notice it's negative on the outside. The negative can never be inside or underneath the square root symbol. Don't ever put the negative underneath there. That makes it an imaginary number. We do not work with imaginary numbers. Not imaginary in that it's not a thing, imaginary in that it's not a real or rational number that we work with. Alright. So now, we're going to break this down into factors. Negative 32 is going to stay on the outside, and we're going to see if we can pull anything out. So let's start with 75. 1 times 75, no perfect square factors. 2 is not a factor, but 3 is. Is there a perfect square in that pair?
Yeah.
25, right? So we're going to write negative 32 times the square root of 25 times the square root of 3. Does everybody know how we got there? Okay, now we're going to work on our variables. We're going to write these as perfect square factors. Well, 8 squared is a perfect square already, so we're just going to bring that down. But k cubed, not a perfect square. Can we write k cubed as a product of a perfect square and another factor? K times k times k. Isn't that k squared?
Yeah.
So we're going to write that as k squared times k, because that's what k cubed is, right? So times the square root of k squared times the square root of k. Now at some point you're going to get a little bit better at this if you practice, and you don't have to write every single thing out like this, but for now I want you to do that. So what's the square root of 25? 5. So we're going to cross that out and put a 5. Is 3 a perfect square? So it's going to stay under the square root. What's the square root of 8 squared? The square root of k squared. Square root of k to the first has got to stay under its radical because it's not a perfect square. So everything that's not under a radical now gets multiplied. Everything that is under a radical gets multiplied. So this is negative 32 times 5, which I think is negative 160, but I'm going to do it on here.
Yeah, negative 160.
Okay. So negative 160, but we also have these variables, h and k. So remember, without a symbol, that means negative 160 times h times k, right? And now, so we've gotten rid of all this stuff. Now all we have left are the radicals, and we can put those under the radical together. The square root of 3 times the square root of k is the square root of 3k. So that would be your final answer. What do you think?
Yeah. 5.
Alright, you want to do one with the fraction on the outside?
Yes, please.
Alright. So we're going to do this one. Do you guys see with this? Everybody see with this? Everybody caught up with me? Ah. Alright, so we are going to rewrite number 12 in a bigger space. If y'all are through, I'm about to erase. Let me know. Are y'all all through with this? You can trade me. Yeah, there's one in the cup up here. Look for one that's sharpened up here. Alright, I'm going to rewrite number 12. It's going to be 1/2 times the square root of 72 times 3 times the square root of 48. We could multiply 1/2 times 3/2 to start with. And that's going to be 3/2. Everybody agree with that? You can do that on a calculator. 1/2, 1 ABC 2 times 3. 1 ABC 2 times 3. That's 1/2 over times 3 over 1. Now, sometimes we multiply these together, but I would not do that for these numbers, right? Because I can see already what the perfect square factor of 72 is. I can see already what the perfect square factor of 48 is. If I multiply those together and get a big old number, I'm not going to recognize that. I already see it now. Anybody know what is the square root factor of 72? Look at your list of perfect squares that we did. Are any of those a factor of 72? If you're not sure, 1 times 72, 2 times 36, right? So how you find that is it's an even number, so it has to be divisible by 2. So you take 72 divided by 2 and you'll get the other factor, right? So we're going to write this as the square root of 36 times the square root of 2. So far so good? Now does anybody recognize the perfect square factor in 48? DePaul? It is 16. If you didn't recognize it like DePaul did, try 1 times 48, 2 times 24, 3 times 16. Take 48 and divide by 3, it'll give you that factor. So 16 is a perfect square, so we're going to do times square root of 16 times the square root of 3. Now we start simplifying. What's the square root of 36? We can't simplify the square root of 2, right? That's not a perfect square, so that stays. What's the square root of 16? 4. So now we're going to take 3 halves times 6 times 4 times the square root of 2 times the square root of 3, which is the square root of 6. I want you guys to practice doing this on your calculator. So it's 3 ABC 2 times 6 times 4. What do you get? You don't have to be able to do anything with fractions anymore because your calculator will do it. What did you get? Say it again? 36.
Wait, 36?
Yes. So 3 ABC 2 times 6 times 4, you should get 36. And that 36 times the square root of 6 is just written 36 square root 6. Any questions? Look at this word problem. Are you with me? What happened? There we go. All right, let's look at number 19 because it's similar to your 22. So I'm going to tell you what to write so you don't have to write the whole thing. So we've got, you're going to write rectangular room. And you're going to say the width. It tells you here the width is 2 times the height. So the width is, that's equals 2 times the height. This is example 800. I don't know how many examples we've done now, but this is the next example. This is example for number 22. It's going to look like number 22 or similar. So a rectangular room, the width is 2 times the height, and it says each section has a brace that connects 2 opposite corners of the room. What is a simplified expression for the length of a brace? Heavens, Murgatroyd, Batman. Rectangular walls. The width is 2 times the height. So, height and width. Does that make sense? All right, so each section, so this is a rectangular wall. This is the wall. Each section has a brace that connects two opposite corners of the room. So like that. What is a simplified expression for the length of the room? I don't even know if I've drawn the diagram right. All right, take it back. We're not doing number 19. I'll talk to you about number 19 tomorrow.
So, we got on the paper?
Number 22. Number 22 is not like that one. Number 22 is much easier than that one. We can talk about number 22 on your paper. Actually, it is like number 22, but I don't know why it's not making as much sense to me. All right, so let's do this. All right, so we're going to look at one brace. So what is a simplified expression for the length of a brace? Oh, I think you got to be able to use the the Pythagorean theorem. Yeah, we're not going to do that one. Skip number 22. We're going to work with the basics today before we get into anything that complex. We may do 22 together tomorrow, and then you guys can do 23. Okay, so you have 10 minutes. You normally don't have any time left to work, but you have 8 minutes before you can pack up. I'll let you pack up at 2 minutes before the bell. That means you have 8 minutes to work. No, we didn't do your homework. We did different examples off of another version of your homework. Yeah.